Hi everyone, this is an introduction to how to solve trig equations in this form. So it's just not theta, it's 2 theta. And what I did I'm just going to do this one problem, and the next videos will be where I'm not always graphing it, but I wanted to show you what's happening. I graph sine of 2 theta, and if you recall from graphing that when you have the 2 here, this is your period. That means there's 2 cycles from 0 to 2 pi. So that's 2 waves here. Okay, so, and remember that we had 2 pi. Your period is 2 pi over your b, or whatever this is. This would be your b. And if you do 2 pi over 2, you get pi. So the sine wave makes a complete rotation from 0 to pi. Now, normally, what you do is, if it was just sine of theta equal 1/2, there would be 2 solutions. And you know what those solutions are if you know if you just drew the regular graph here. But in this case, we have 2 waves, and if I look at my 1/2 here, it's going to hit here and here, and here and here. So we're actually going to have 4 solutions. Now to figure those out, what we're going to do is use this thing of acting like this is theta. So what would theta be? So if I just did sine of theta equals 1/2, then I would get pi over 6 and 5 pi over 6. So I want, and I'll write this again, my sine of 2 theta here, I want the 2 theta to equal pi over 6 or 5 pi over 6. Okay, and 5 pi over 6 actually. So what I do is we want this to equal these two, so I set it to equal it. So I'm going to write the general form for this. We know that theta is pi over 6, and then since the period of pi is 2 pi, the period of sine is 2 pi, I'm going to write 2 pi k or 2k pi. Should have probably put 2k pi. Doesn't really matter. And then also, I'm going to have 2 theta equals 5 pi over 6 plus 2k pi. And then to solve for theta, if we allow this to equal theta, you divide everything by 2. So you get theta equals pi over 12 plus k pi. And for the second one here, we get theta equals 5 pi over 12 plus k pi. All right? And I'll show you what I mean for this right here. So I'm going to go on the next slide, but I just want to show you what this means. That means that this solution right here, and I'll put it down here, that's going to be pi over 12. And this one right here is going to be 5 pi over 12. Now we also have to get these 2 solutions. We have to go all the way to 2 pi. So this is what we're using the general formula for this 2k pi. Now let's go back and let's go to the next one. I'm going to show you what's going on here. We have sine of 2 theta equals 1/2. We already know that it's pi over 12, and let me show you why. I'm going to plug in my pi over 12 for my angle. That means sine, if you multiply this out, you get pi over 6. And we know that sine of pi over 6 is 1/2. Similarly, you can do it also with the other angle we found, which is 5 pi over 12. So if you multiply 2 times 5 pi over 12, you're going to get sine of 5 pi over 6, because 2 goes into that 6 times, equals 1/2, which we already know. Okay, so basically that's just a check. We know that this is true right here. And what I want to do is go from 0 to 2 pi and find the solutions. We already know from the graph that we have 2 more solutions, because if you look here, we have to get this point right here, those 2. All right, so I'm going to rewrite this since I know now my solutions are involved in 12. I know I can go from 0 to 24 pi over 12. Because 24 pi over 12 is 2 pi. And the way you do that, you can start with -1, but I'm not going to because pi over 12. We're going to try k equal 1 or k equals 0. And in that case, we have theta equals pi over 12 plus 2k, it's just k pi. Well, if k is 0, that's 0 times pi. And we also have theta equals 5 pi over 12 plus 0 times pi. Well, that just leaves you pi over 12 and 5 pi over 12, which is we already knew those were our solutions. So we got to see if we have more solutions here. And so what we're going to do is try k equals 1. That would be pi over 12 plus pi, 1 times pi. And theta equals 5 pi over 12 plus 1 times pi. Now, to add pi to this, we're going to get pi over 12, and this is going to be 12 pi over 12. Because 1 times pi is pi. This equals pi. And that gives you 13 pi over 12. So that's going to work because it's less than 24 pi over 12. Now let's try this side. We're going to get theta equals 5 pi over 12 plus 12 pi over 12. And that's going to give me 17 pi over 12. So my other 2 solutions are 13 pi over 12 and 17 pi over 12. And I'm going to go back and put them in. So I have this one right here is 13 pi over 12. And this one here is 17 pi over 12. Those are my 2 solutions. Now I'm going to go ahead and try k equals 2. So that's going to be theta equals pi over 12 plus 2 pi, because that was your k, and theta equals 5 pi over 12 plus 2 pi. And when you look at this first one here, you have pi over 12 plus 24 pi over 12. Clearly, just looking at that, we're adding a 2 pi here. It's going to be too big. So that's 25 pi over 12. And that's bigger than our 24 pi over 12. Because we only want it from 0 to 24 pi over 12. And then clearly this one won't work as well because that's going to be too big. So our solutions are pi over 12, 5 pi over 12, what was the other 2? 13 pi over 12, and 17 pi over 12. Now, that's just a way to do it. You don't always have to graph these to know how many solutions. So basically we're going to use this k thing, which is your number of rotations. and k is an integer. So, all right. The next ones we're going to do the same way. It's just I'm not going to graph them, and we're going to use the same procedure. Thank you. Have a nice day. Bye-bye.